So in this video, we are going to be looking at problem number 3 on the taco cart problems. In this problem, we are going to try to minimize the time that it takes to get to the taco cart. So in order to minimize the taco cart time, the time from the current beach location to the taco cart, we need to think about this in terms of time 1 and time 2. Time 1 being the time it takes to travel across the beach. Time 2 is the time it takes to travel across the road. We know from given information that the distance on the left there would be 325.6, and the entire distance length to length here was 562.6. So if we cut that into two segments, x and 562.6 minus x. So the total time is going to equal the time it takes to go along the beach plus the time along the road. Time 1 can be found by first finding the distance, d1, by using the Pythagorean theorem. X squared plus y squared equals z squared, or whatever lettering you want to use. It would be 325.6 squared plus x squared in this case. Take the square root, and that would be the distance 1. If we want to find time 1, we then divide it by the rate, which is 2. So distance 1 divided by rate 1 gives us time 1. The other distance that we're going to be traveling is 562.6 minus x, and that portion of the trip will be done at a rate of 5 feet per second. So we divide by 5, and that gives us time 2. So this is a function here for total time. Time, and as a function of x, equals this whole expression. So at this point, what we need to do is minimize that expression. So we'll go to the calculator in y1. We'll type in the square root of 325.6 squared plus x squared. We'll get out of the square root portion there. We'll divide by 2. And then we'll add in the other portion, which is 562.6 minus x. I need a set of parentheses in there, though. Oops. Okay, so let's insert parenthesis. Put a parenthesis at the end there. And this rate was 5, so we'll divide by 5. Go into my window. I can still use a window of 0 to 562.6 because that's what my x value would have to be. And the times are probably going to be somewhere between 0 and 500. So I'll graph that and see what happens. Okay, so I get that. Now I go to second calculate. Minimum. And since my window, my x min and max are 0 to 500, I think I put in there. Minimum 142, and when the time is the x that creates the minimum time will be 142, the minimum time being 261.7. All right, so going back to our problem, that tells you if you want to minimize the time, you should put the taco cart, or your aiming point should be 142.1 feet from this corner right here. Thank you.